Hello everyone. In this numerical problem, we need to find slope at B and the deflection at C for the simply supported beam loaded as shown in figure by unit load method. Here, a simply supported beam is given with an varying moment of inertia. In the portion AC, moment of inertia is 2I. In the portion BC, it is I. A concentrated load of 50 kilonewton is placed at point C. We need to find the deflection under this point C and the slope at point B by unit load method. To find the slope and deflection by unit load method, to find the deflection, you need to remove the external load and you have to apply the unit load wherever the deflection is required. Here, in the simply supported case, let us find the reactions by applying the equilibrium condition. Let us take moment about A point. The moment about A is, here we are having VA into 0, then 50 into 3 producing a clockwise moment, plus 50 into 3 minus VB into 5. It produces an anticlockwise movement. Therefore, we are getting vertical reaction VB as 30 kilonewton. Apply another equilibrium condition, sigma V equal to 0. Here VA minus 50 kilonewton plus VB equal to 0. We are having VB value. To substitute, we are getting VA as 20 kilonewton. These are the reaction due to external load. Now, to find the deflection under point C, we need to remove all the external load. External load is removed and a unit load is applied at point C. Now, in this simply supported case, once again we need to find the reaction of this simply supported beam subjected to an unit load. Apply the equations of equilibrium, sigma m equal to 0, take moment about A, V into 0, 1 into 3 produces a clockwise moment, plus 1 plus 3 here minus VB into 5. We are getting VB value as 0.6. Apply another equilibrium condition, sigma V equal to 0, VA upward positive minus 1 plus VB equal to 0. Substitute the value of VB 0.6. We are getting VA as 0.4. Now, in the tabular column, let us take the portion AC first. Let us take A as the origin. Limit is 0 to 3. Moment of inertia is 2I and moment M, capital M, is bending moment due to external load. This is the external load. We need to find bending moment about this portion AC. To find the bending moment, we need to take a section in the portion AC and from the origin, let the distance be x. Here, you can take either to the left of the portion or to the right of the portion. I will take left of the portion since there is only one force. to the left of the portion, here VA into X. It produces an clockwise movement, therefore positive. VA value is 20x. You can see here movement is 20x. Now M1, to get the value of M1, that is bending moment due to unit load, we need to take a section at a distance x from the origin. Here, if you take left hand of the portion, VA into X, producing a clockwise movement positive, VA is 0.4x. Therefore, M1 is 0.4x. The product of M and M1 value is 8x square. Similarly, take the portion BC. Here, B will be taken as origin. Limit is 0 to 2. Moment of inertia is I. Then movement due to external load M in the portion BC. Here, once again, when you are taking the movement, you need to take a section in portion BC at a distance x. Then the moment about this point will be, if you take, I am going to take the right hand portion. Here VB into x produces an anti-clockwise moment. To the right hand of the section, anti-clockwise is positive, the sign convention what we are following. VB is 30x. Therefore, M is 30x for portion BC. Similarly, for unit load M1, let us take a section here in the portion BC at a distance x from the origin. Moment, if you are taking moment about to the right hand of the section, VB into x produces an anti-clockwise moment, positive. VB is 0.6x. M1 is 0.6x. The product of M and M1 is 18x square. You take this value in the formula, delta equal integration 0 to 3, limit 0 to 3, M1 is, for portion AC is 8x square by E into I is 2I into dx plus integration limit 0 to 2, 18x square by E I into dx. Now, here 8 by 2 EI is taken as constant. Integration of x square is x cube by 3. Limit is 0 to 3. Plus constant is 18 by EI. Integration of x square dx is x cube by 3. Limit is 0 to 2. When you calculate this, you are getting the deflection at point C as 84 by EI. This is how to find the deflection by unit load method. In the next portion, we need to find the slope at point B. To find the slope at point B by unit load method, you need to remove all the external load and you need to apply the unit moment at point B. Here, unit moment is applied at point B, wherever the slope is required. In the tabular column, before that, we need to find the reactions due to this unit movement on this simply supported beam. To take sigma m equal to 0, take moment about A, it is V into 0, then it produces a clockwise moment plus 1, then VB produces an anticlockwise moment, therefore minus VB into 5. Therefore VB value we are going to get it as 0.2. Apply another equilibrium condition, sigma V equal to 0, VA plus VB equal to 0, therefore VA equal minus 0.2. In the tabular column, the portion AC is taken, A is origin, limit is 0 to 3, moment of inertia is 2I, moment due to external load remains same, that is 20x, moment due to unit movement you need to calculate. To find the moment in the portion AC, take a section in portion AC at a distance x from the origin. A is the origin what we have taken in the portion AC. Here, if you take left of the portion, VA into x is the moment, representing clockwise moment positive. Therefore, VA is minus 0.2. We will take that value as minus 0.2x. You can see here minus 0.2x, and the product of m and m2 comes out to be minus 4x square. In the portion BC, B is taken as origin, limit is 0 to 2, moment of inertia is I, bending moment due to external load is 30x, it remains same, and here in the portion BC, we will take the moment about the section at a distance x from the origin. The moments will be, if you take the right of the section, VB into x producing an anticlockwise moment positive, VB is 0.2x, then there is a moment, clockwise moment, the clockwise moment is negative to the right of this section, therefore it is minus 1. Therefore, the M2 value will be 0.2x minus 1. You can see here 0.2x minus 1. The product of M and M2 will be 6x square minus 30x. You take these values in the formula, theta equal integration limit is 0 to 3 minus 4x square by e into I is 2I into dx, integration limit is 0 to 2, 6x square minus 30x by e into 1I into dx. Here 4 by 2 ei is constant, integration of x square dx is x cube by 3, limit is 0 to 3. Here 6 by ei is constant, integration of x square dx is x cube by 3, limit is 0 to 2. Then here minus 30 by a is constant, integration of x dx is x square by 2, limit is 0 to 2. When you calculate this, you are getting the slope at point B as minus 62 by ei. This is how to get the slope by unit load method. Thank you.